Hello everyone. Previously we had discussed on the topic queue, right? So today we'll be discussing on the topic LIFO queue, right? So let's get into the definition part here. A LIFO queue is a stack-like structure where the last element added is the first removed. Again, right? So a queue cannot be LIFO, but it is a stack-like structure. A LIFO queue is simulates basically stack, right? So it is a stack like structure where the last element added is the first element, right? So using q.lifo, so this one, just keep this in mind. So we went with just q.q, right? So previously for the q, see here, this one I'm speaking of, right? Q.q, right? So this one, using q.lifo, Python offers a thread safe stack implementation, right? Thread safe stack implementation. Thread safe, what implementation? Stack implementation. That is the reason we'll be going with the LIFO queue, right? So this is fine. Now let's get into the example part. Let's see the same through the example, right? So I'll just go with from queue. So this one will be import LIFO queue. So this is fine. Now I'll just give LQ variable, nothing but the LIFO queue. So let me pass here LIFO queue function. So parenthesis, this is fine. I'll just go with LQ dot this provides put operation. Basically I'll just go with the put, means we are adding the elements here one. So let me copy the same thing and make the necessary changes over here, man. So this one, let me change from 1 to 2, and this one let me change from uh, 1 to 3, right? So now let's do one thing. Let's pop. So I'll just go with the, for the interactive purpose, right? So we have made use of the put. Now let's go with the popping. So I'll just go with the popped within the strings, and then let me go with the get operation. Popping means we are getting the element, right? So I'll just make use of lq dot get. This is fine. Again, so let's do this one more time so that we'll understand this one clearly. So what we have done here, I have imported the this one LIFO queue, the first one, right? So this one, uh, now we are creating the empty LIFO queue. First, what we are doing, we are creating the empty LIFO queue. Then we are putting the items into the queue by making use of the put operation that LIFO queue provides, right? So this is fine. Finally, we are getting the items, nothing but we are removing the last inserted first. Means we are getting the items, means we, it removes last inserted first. So again, why it removes the last insert first? It's not similar to the queue, right? First has to be removed first, but this is LIFO queue, right? So this is LIFO queue. See here, Python offers us this one using LIFO queue.LIFO, Python offers a thread safe what implementation? Stack implementation, right? So we are getting the items, means we that removes last inserted first. So first we need to get the output 3. First we are removing the last element, right? 3 we have to get. Second, we are going with lq.get twice, so we have to get 3 and 2. We have to get 3 and 2, popped 3, because we have given popped within the strings. So popped 3, then in the next line we have to get popped 2, right? So let's check the same. So I'll just give your Python. So let me copy the file name. Array, did I delete it? So I'll just give you a control C, man. Yeah, my bad. Sorry, just give me a second here. Python. Uh, sorry, clear this one. Let me give you a Python. So let me right click here, rename, or you can just give F2. So let me paste this one dot py, right? So we are getting the output pop3, pop2, right? Which gives means we are getting the desired output, right? So this works absolutely correct. LIFO works absolutely correct. This is giving us the desired output, right? So we are done with the concept LIFO. Now let's do one thing. I'll just summarize whatever we have learned so far, right? So LIFO queues work like stacks basically, right? What it does, LIFO queues work like stacks and are useful for backtracking problems. Where it is useful, and are useful for backtracking problems, right? So in the future, so I'm thinking of doing some LeetCode problems on this one, Python, not for the YouTube purpose. So while giving the contest basically, so this saves lot of time, man. Really, Python saves a lot of time basically. So let's see, the first two problems I'm thinking of doing it in the Python. So in the future contest, for now I'll be doing it in Java itself, all the problems. So when it comes to competitive coding, so we'll be doing it in Java itself. We'll never go for any other programming language. I'll be strictly doing it on this one, Java itself. Whether it I'm speaking of the this one, CP basically, Codeforces and the code chef I'm speaking of. And this one LeetCode, let's try with this one as well, Python, in the future contest. Let's see. So if we get time and if I want to implement, I'll just go with the Python as well, right? So now we are done with the LeetCode, and let me summarize whatever we have learned so far, right? So again, so LeetCodes work like stacks and are useful for the backtracking problems. Just keep this in mind, man. Next, we'll be discussing on the simple queue, right? Next, we'll be discussing on the simple queue. For now, this is it. Thanks for watching, guys.